Hey everyone, welcome to our YouTube channel, and in this video we are going to cover introduction to flip-flops, a very important topic of digital electronics, and we will learn about the flip-flops in about 5 minutes. So this video is useful to any individual who in generally wants to learn what are flip-flop all about or is currently pursuing their engineering degree across the world. So basically this digital electronics topic is highly important if you are basically, let us say, in your freshman year or maybe first year or second year, whatever. Now, so the first thing that we need to understand is there is this circuit which is known as a combinational logic circuit. Now you might have seen many combinational logic circuits in your curriculum. So basically what happens is that in the combinational logic circuits, in the last lectures that we covered, the output level of such circuits at any instant of time are dependent on the logic levels which are given at the time of the input. So basically what happens is any prior input logic level conditions, they have no effect on the present outputs. So this is due to the fact that basically the combinational logic circuits have absolutely no memory. All they do is just process the input what is given to them. However, it's quite interesting to know that most of the digital systems are basically made of combinational logic circuits, as well as they have certain memory elements attached to them. And the most important memory element is essentially called a flip-flop. So basically what this will do is kind of preserve some information that has come in from the previous circuits and then use it in the like in the sequence that is about to follow. So the flip-flop is made up of basically an assembly of different kind of logic gates. And it may be noted that even though a logic gate, it is a logic gate by itself, but it has no storage capability. But such logic gates, when connected together in ways, so basically they help in permitting the information to be stored, and several different gate arrangements are then used to produce these flip-flops. So if I draw a very simple diagram of a flip-flop, it somewhat looks like this. So let us make a box and write F here. So this basically represents a flip-flop. Now what I will do is, from this side we provide it the input. So this is the input side. Now what happens is that there are two kinds of output here. So first, what is called a normal output. Let me write this as normal OP, and on this side what we have is known as the inverted output. So this basically is represented by a symbol Q, and the second one, that is the inverted output, is represented by the symbol Q bar. So as seen from the diagram, the flip-flop basically has two output labeled as Q and Q bar that are inverted complement of each other. Now the output Q, which is this one, this is called a normal flip-flop output, and Q bar is called the inverted flip-flop output. Now it must be very carefully noted that whenever we refer to the state of the flip-flop, what we are basically referring to is the normal output stage. So on the other hand, if we say that the flip-flop is in the lowest state, so this basically is representing the inverted. So this one represents the high state, which is the normal output, and this one represents the lowest state, which is the inverted output. So essentially what happens is that there are two possible operating states of a flip-flop. One possible state is that the value of Q is let me shift this a little bit. Okay, so what happens is that there are two possible operating states of the flip-flop. One possible operating state is that we take the value of Q as 1 and the value of Q bar as 0. So this basically represents the first case, or case number 1, whatever you would like to call it. Now the state Q equal to 1 and Q dash equal to 0, so basically this state is called the high state of a flip-flop. And what happens is that it is also known as the set state. So in the set state, what happens is there is a normal output which gives the output as binary 1, and the Q bar gives you the output as 0. Now in a similar way, the state Q equals to 0 and Q bar, if you reverse that, let us say Q is equal to 0 and Q bar is equal to 1. So now this will have a totally different meaning. So this first of all will refer to as a low state, and the other name for this low state is known as the clear state. And this is our second case. So as you can see, there are two possible outputs referred to as the high state or the set stage, and the low stage or the clear stage. Now this clear stage in some of the curriculum is also referred to as a reset stage. So it may be noted from the flip-flop that a flip-flop can have one or more of these inputs right here, and these inputs are then used to switch the flip-flop back and forth between the two possible output states. Now it will be shown in the later lectures that most flip-flop inputs need only to be momentarily activated or pulsed in order to cause a change in the output state. Now the flip-flop output will remain in the new state even when the input pulse is over. So basically what is happening is that this particular characteristic is providing it a memory characteristic. And it is also interesting to know that the flip-flop is also known as a latch and a bistable multivibrator. Now the term latch is used for certain types of flip-flops that will be discussed in the coming lectures from now. And the bistable multivibrator is more like a technical name of the flip-flop, is the one more frequently among the engineers and the technologists. So I think that's it for now. I hope that this video about the flip-flops was innovative and some kind of information you might have seen. So I hope to see you in the next video. Thank you so much for watching.